All right. So welcome everybody. This is our next edition of the Ask a CEGian webinar. We have a very good topic today, how to choose a career vector by Bhaskar Ramachandran, who is an ECE 2002 alumnus. Thank you, Bhaskar, for participating and helping. And we have all students joining in. And as we do that, a few webinar logistics. Please mute your audio and video. You will have the opportunity to paste your questions on chat. And we will also open up audio discussions towards the later part. And or if Bhaskar wants to do that during the call, that's fine too. So without further ado, Bhaskar, please take it away. I will actually make you a co-host as well so that you can present.
Thank you, SK.
All right.
Shall I go ahead and share my screen?
Yes, please. I will stop sharing and you can please go ahead and share.
Thank you. Okay. My computer is a little bit slow, so I'll try the PowerPoint slide presentation, see if it works, and then I'll get started. Okay, I think I need to switch the screen. Please be patient with me. My laptop just got a Windows upgrade and it has been very sluggish since this evening. Okay, I think I got the slide up and running. Are you able to see my screen?
Yes, we can see the slide.
Okay, great. Okay, first of all, a very good evening to those who are in India and a very good morning to those who are joining from US. My name is Bhaskar Ramachandran, ECE 2002 batch alumnus. And today we are going to talk or discuss about choosing the career vector. Let me get started. Okay. All right. Oops. Okay. In this webinar, I'm going to talk about 6 simple steps that students can actually take up as they navigate from their campus life into their, like a corporate world. And we have heard a lot about the industry-academia gap. For those who are not aware, there is a mismatch, we say, between what we learn in our college, in our academia, and what is actually used or what is relevant to the industry. And this has been in the discussion for several decades, actually more than 2 decades now, since when I graduated and even as of today. And there are a lot of things that have been done both by the industry and by the academia. And some of them are like making the courses becoming online, available online for anyone to access so that the knowledge is shared much more. Anyone can access any material online. All the courses are available for free online. And also from the industry side, there are a lot of industry-sponsored research activities that is going on, and even universities are allowing industry sponsors to set up courses, and industry experts go and teach those courses to students. So that way, a lot of activities have happened in the past to bridge this gap. Based on my interaction with students for the last about 10, 12 years, I have been interviewing a lot of students, and I'm also coaching students when they actually join, when they take up a job. And I interact a lot with students. I have been having a very strong conviction that this problem of the industry-academia gap can be best handled by the students. Like if this problem is taken up by the student, then it can be solved in a much better way. My laptop is quite slow, so let me see if I can get out and I'm not able to move the slides. Just give me a second. I don't know whether it is a bandwidth issue or what, but just give me a few seconds. I will try to fix this. Okay. Are you able to see my screen?
Yes.
Okay.
Yes, screen's fine, Bhaskar.
Okay, fine. Okay. All right. So this problem of the industry academia gap, what I feel is it's best if the students take that problem and try to solve it. So in this webinar, I would be exploring a few steps that the students can take. And as we go through these steps, I also have a few simple questions for students. If you can actually respond to those questions via chat, that would be great. So let's get started. And also the examples that I'm going to give here, they will be more relevant to students with the electronics background. But even if you are not from the electronics background, the entire flow would still be relevant to anyone who is pursuing engineering. All right. Okay, let's get started with the first step. The first part is to understand what the curriculum that we are learning in college and how it maps to our industry, right? So are you able to see my screen? Is it in the presentation view or is it in a different view?
It's in presentation.
It's in presentation view.
Okay, all right, thank you. Yeah, again, there are some problems with the slides. It's not moving very well. Anyway, I'll continue. If there is any problem in seeing the slides, if there's a disconnect between what I say and what you see, please stop me. Okay. As a first step, I think if we can understand what we learn in our college, what is the curriculum that we go through, and what are the various engineering roles that we have in the industry, right? So that understanding will help us choose the right courses as we go through our academics. And as you know, there are some core courses that we go through. So I'm showing those core courses in rectangles. And any student pursuing electronics engineering, they would be taking those core courses. And you're left with a lot of other courses which are mostly elective, right? How do we choose those electives, and how do we make a fit with those electives to the various engineering roles? So here I'm trying to make an animation where it shows the different courses that you can pick and the various engineering roles on the very top, right? So these are some of the courses that you can pick, and that will help you get into a different role in the industry, such as like analog engineer or power electronics engineer and so on. right? Based on the elective courses that are available, one can come up with a map like this so that it will be easy for us to decide what courses are relevant for the roles that we are aiming for. A sample career map can be something like this. We take all the core courses and then we pick some of the electives such as electronic circuits 2, CMOS analog design, mixed signal IC design, and power electronics, in case someone is aspiring to become a power electronics engineer, right? And in addition to these elective courses, you can also look for some additional online learnings. There are some excellent YouTube videos from Professor Ben Yakov. There is this NPTEL lecture, and also very good courses from Coursera on power electronics. So those will actually supplement what you will be learning in your college curriculum. And that would help anyone aspire to become expert in a particular domain. Right? Okay, here is where I want to get some feedback from students who are listening to this webinar. Sorry for going back and forth on these slides. It's not moving at the pace I click them. Okay, I hope now you can see the curriculum map feedback slide. What I hear a lot from students is like, there is no clear idea what path to pick. There are so many courses available. So in case you are in that bucket of like you don't have a very clear idea what path to pick, then you can respond with a choice 0. Or in case you have some idea what you want to focus on, and you think you can figure it out yourself, then you can respond with 1. In case you need some help in figuring out what engineering domain will be a best fit for you. There are various roles I said, like analog design or mixed signal design, digital engineer. So if you want to know more about those different roles, then you can respond with the choice 2. Or if you think that you have enough research done on various engineering roles and you have a clear idea what you want to pursue, then you can go with choice 3. If you can all take a few seconds to respond in the chat, I'll see if I can access the chat. That would be great.
Thanks, Bhaskar. So we're seeing some answers coming in the chat already. I see a couple of 2s. So yep. Please put in your responses onto the chat. We're at 4 2s so far. 5 2s. 6, all 2s actually.
Okay, that's good. Thank you. All right, so this feedback that you're providing will help us also interact better in future. So that's one of the key reasons I would like to hear from you, from the students, at what stage they are, so that we can have a better productive discussion in future. So thanks for your feedback. I will move forward.
We are not able to see your screen, sir.
Okay, I'll share it in a moment. I'm very sorry about this laptop not actually responding as I expected to. Let me share it again. Okay.
No issues. Yeah.
Do you see my screen
now? We are seeing a desktop screen right now.
Got it. Got it. Okay. Yeah, I'm getting there.
We can monitor the chat for you, Bhaskar, so don't worry. We can read the responses out, so you can
Thank you.
Just focus on the presentation.
All right, thanks.
We see it now.
Okay. All right. So moving on to the second step, right? So we now know the curriculum and how it is mapped to the different engineering roles. The second key step is to actually getting our career vector right. Like what it means is we need to understand what are the opportunities available to us and what is it that we want to have as our goal, and also finding our mentor and to get a reality check of where we are and what needs to be done to achieve that goal. So I'll be going through this second step, which is one of the key steps. All right. So imagine that you are right in the middle where there is a rocket placed, and you have all these opportunities all around you, right? There are various companies, there are these promising startups, which are in blue, the Aether, AMS, Cirrus Systems, Semtronics, CarIQ, Greenwatt Semiconductor. These are some of the hardware-related startups, which are very promising. And you also have different companies like services and product companies like HCL, Wipro, Tessol, Solitron, and so on. There are other multinational companies which are color-coded green, like Rohm Semiconductor, Cadence, Synopsys, Infineon, Metagraphics. And then finally, you also have these Fortune 500 companies. Some of you might call it as dream company, such as onsemi, TI, Samsung, Google, Broadcom, and so on. Right? You also have your own startup idea. I have placed it on the top left, right? So that is also another option for all of you. Now, we need to know what are these various opportunities that are available around us. And based on the inclination that we have when we do our undergrad, we have certain likings for certain subjects. We know that we are good at certain things. So based on that, we need to orient ourselves and we need to have a target. For example, in this case, you may pick like Texas Instruments. I want to become an engineer in TI. And then we need to figure out a path from where you are to how to get there, right? How to get to TI. Now, your goal need not be so specific, like I want to become an engineer in so-and-so company. It can even be general. You may say that, okay, I see that there is a lot of EV, electric vehicle coming up. I want to do something in the EV space. Or you can say like, I like motor design and I want to become a motor expert. Or I want to get into home automation. It could be anything. It need not be too specific. It can even be general. But this is something that a student, if can figure out in their third year or so, then the student can actually make some preparation towards that goal. So it becomes very important to have a kind of goal so that we can aim towards it. Right. Okay. Now, now that you have a certain goal, now the next question is, how are we going to accomplish it, and how are we going to find out where we are with respect to the goal? So here in this example, I'm going to pick analog design at TA. I want to do analog design at TA. Okay. Now, can you achieve this goal with the knowledge that we have and the remaining time? So what do I mean by remaining time? It is the time that you have until graduation, right? So that is the time that is with you. And also you have certain amount of knowledge right now. And with that knowledge and time, is it possible to achieve that goal? That is a key question to ask ourselves. And how do we figure that out? That is where mentor comes in. So you need to find a mentor who has been through that, who knows what it takes to achieve that goal and can give you a reality check. This is a very important thing. I see many students who have certain goals, but they're finding it very difficult to achieve it because they don't have the right guidance. I have interacted with a few students who wanted to be in TA, but then they were too late, or they were not having the right direction, and they were not taking the right courses to get there. So finding a mentor to get a reality check is important. With that reality check, you can either modify the goal or put in effort in the right direction to achieve that goal. So either one of them can be done. Now, how do you find a mentor? That is another key thing. Having this mentor is invaluable because a mentor can give you a lot of guidance and save you a lot of time in your picking the correct career path. Now, there are a few ways you can find your mentor. Right? It's you all mostly know it. Your seniors and your college professors, right? They are great mentors for you. You interact with them on a daily basis. So they are wonderful mentors for you. You are spending a lot of time with them, so they can be your mentors. You can just ask them to be your mentors and give you your guidance. The other way you can find a mentor is through LinkedIn. There is a professional network, and you can find engineers who share their thoughts in LinkedIn, and you can request one of them. You can pick someone who is in the same path, in the direction that you want to go, and you can request them to be your mentor. Or you can also approach your alumni network, and they can also be of great help, such as this one. You can find someone who has gone through the path that you are going through, and they can guide you really well. Right. Now, having found a mentor, what you can do is you can request the mentor to evaluate you. Right. You have a certain goal, and now you ask the mentor to give you an assessment. As of today, let's say you're in your third year or second year, whatever it is, or even fourth year, you can request your mentor to give you a technical assessment. Like, this is my goal, and can you tell me where I am with respect to this goal? Right. So the technical assessment can be done by the mentor, and the mentor will give you a feedback. Right. So then you have something concrete to work upon. That is the mentor feedback. Now, in our example, we're going to have the goal as analog design at TA, and you tell your mentor, and the mentor gives you an assessment, and your mentor assessment could be something like this. Let's say the mentor says you have strong RLC and MOSFET basics. You are good in resistors, inductors, capacitors, and MOSFETs. However, your feedback concepts are a little not so strong, and your IC design fundamentals have to be strengthened. You're a little bit weak in that. However, you have very strong analytical skills. And finally, you also have to improve on your clarity of thought, the way you communicate and you respond. You may have to improve your clarity of thought. So this is a sample feedback that you can get from your mentor, right? This is as of today, like when you have that assessment, you may have one more year to go. This is the feedback that you can get from your mentor. Now, what can we do with that feedback, right? That is the next question that we will discuss that in the next step. Again, once again, I would like to seek your feedback. Some of you may have a mentor, some of you may not have. So in case you do not have a mentor and you also have difficulty identifying the right mentor for you, please respond with 0. And in case you don't have a mentor, but you think you can connect with people, the various ways by which you can find a mentor. If you are confident that you can find your mentor, then please respond with choice 1. And if you have a mentor and you can approach that person for any technical support, and you're going to do that pretty soon, then please go with the 2. And finally, if you think you have figured out your career vector, you know what you want to do, and you're working towards that to accomplish that goal, you please go with choice 3. So may I request students attending this to give a response, 0, 1, 2, 3.
We are seeing 3 zeros so far, 4. 4 zeros and a 1.
Okay.
6 zeros and a 1.
Okay. So many of you looks like don't have a mentor, and you're also having difficulty identifying. Okay. Thanks for sharing that. No, this is something we can definitely work upon. Like, we have this alumni network. We also have a lot of engineers in the industry who are really willing to work with students. Like many of my colleagues, when I discuss with them, they are actually very passionate about teaching. That's interesting because once we learn a lot, we also tend to share it, right? So I know a couple of my colleagues who are interested in mentoring students. It's only thing is like there is a lot of desire on one side, and there are a lot of students who need that. I think we need to find a good match. Certainly, we can work upon that. So thank you for sharing your feedback. We will move on. Yeah, I'm just waiting for the slide to go to the next one.
In the time you're waiting, Bhaskar, is it okay we see a couple of question on the chat? Can I read it and can you take it?
Yeah, sure, please.
So KG asks, how long into the career vector one has to think at step 1 or 2? What resources do we have to take a decision?
Okay, very good question. Thanks, Kumraguru Sivasankaran. Okay, so the step 1 is where you actually look at your curriculum map, right? So you have certain core courses which you will be taking in first year and second year. And when it comes to near the end of second year or third year, that is when you will be choosing your electives. So by the third year, if you have a clear idea what courses that you want to take or what is your career vector is going to be, right? So that would be a very appropriate time for you to think about your career map and what you want to do, things like that. So how would you know what are the various roles available in the industry, like analog design, digital design? You can certainly talk to your mentor or discuss with your seniors what are the roles. Will you really like that role? Do you want to become an analog engineer or a digital engineer? So that you can have the discussion when you're in the second year. And by third year, you will have the clarity to make those decisions, what electives you want to take, right? And to have a mentor, you can have your mentor even when you're in your first year, right? First year, second year, but a mentor becomes very crucial when you're already in the third year. I would say that by end of second year, everyone should have a mentor who can share their knowledge with the student and guide them. So that would become very crucial at the end of second year, I would say. Okay, hope that answered the question. Any other questions? Okay. All right. Finally, the slide also moved. Okay, the third step. Now, we know we have now a goal, and we also know what is the feedback that we receive from the mentor. Now, this step, third step, is actually a call for action. We are going to build our resume. And the way we're going to make the resume is a little different. We are going to make our resume act as a blueprint, which is going to call for the action that we need to take. Okay, so let's talk about resume building. Okay, so between you and the hiring manager in the target company, right, what are the channels of communication? How do you communicate your skill sets and your aspirations? How do you communicate that to the hiring manager? What are the channels that are available? Let's look at that. Okay, one channel is through technical videos. The other one is through LinkedIn posts. So what do I mean by technical videos? You can actually create a video. You can post it in YouTube. You can talk about some technical topics, and you know, like, you will get more visitors. And if the video is really good, then it will get noticed by more people. And you can also put that link in your resume, or you can share it in your LinkedIn post. So that is one way to show what your skills are. And you can also share technical stuff in LinkedIn. You can write an article and share it in LinkedIn. And many of the hiring managers are in LinkedIn because they are looking for candidates like you. So that is a very good communication channel to get to a hiring manager. What are the other channels? Resume is one of the very powerful channels. Like, any hiring manager has to look at your resume if they want to hire you. So that's a very standard way of communicating your skill sets to a hiring manager. And then there are a few other ways, like you can write some publications, you can put a blog, or you can create a website. You can share whatever you have learned through those websites, and you can also publish papers which will get read by the hiring manager. So these are all the different ways in which you can share your skills with the hiring manager. Now, among this, the resume is the most powerful one, and I'm going to talk about writing a resume. How would you go about writing a resume? And I have looked at a lot of resumes the last 12, 13 years. I wanted to share my thoughts on how a resume can be written. There are lots of materials available online suggesting how to make a resume, what to say, what not to say. I will just share my experience and what I think is a very powerful way to create a resume. Okay, so what I'm showing here is a sample resume. I'm going to leave out a lot of other stuff. Just focus on a few things that you will put in your resume. Here, let's say a candidate is creating a resume and sharing the skills or the knowledge that is gained. There are statements like, I'm familiar with RLC circuits, I have taken these elective courses, I have completed some online course, I have participated in these technical conferences, I'm familiar with these tools, I know these programming languages, and I did some oscillator design. That is what this candidate is showing as resume. But when a hiring manager looks at this resume, the first thing that he or she notices is there is nothing very concrete in this. There are many things that are said, like taken elective courses, taken online courses, but what is the outcome, right? So that is not very clear from this. So this is not a really good way of writing a resume. This is not what the hiring manager is going to be impressed with. Now, how else can you write a resume? Right? What is it that will really catch the attention of the hiring manager? Okay, something very similar to what we said earlier, but here in this resume, if you see the first bullet, it says a thorough understanding of RLC circuits. So the hiring manager is not interested in your familiarity with something, but he wants to know whether you're really thorough in something. If you're not very thorough in something, it's better to leave it out rather than say that I too participated or I too am familiar with it. So he's looking for thorough understanding, and he's going to ask you questions. So you are also challenging the interviewer that you can answer anything in the topic. So you put something which you are very sure about in your resume. The second bullet, what it says is you have actually gone through a lot of online courses, and you have come up with a survey of various op-amp topologies. It's just an example. I'm just picking some op-amp topology here, and you have summarized the pros and cons. So what are we conveying here? You're not just saying that you have attended a lot of lectures online. What you're saying is you have watched a lot of things, you have learned a lot, and you have summarized the learning into a literature survey kind of a post. And you're also providing that link online. You are saying that the article is available at some place online. You're sharing it in your website or something like that. So this clearly tells the hiring manager that you have actually learned something out of all those lectures, rather than saying you have taken so many courses. This is something more powerful to communicate to a hiring manager. And if you go to the third bullet, here what you're saying is an oscillator design. You're not just saying what is the block that you worked on, but you are very detailed. You are giving very quantitative information here. You are quantifying what you have learned or what you have designed. You see there are things like what is the process technology, what is the tool that you used, and what is the specification. Like here it says 100 picosecond jitter across process voltage and temperature, and what is the supply and temperature range that you make the design with. And this gives the hiring manager an idea that you have given attention to detail, and you have actually achieved a moderate level of complex specification, right? And also you're sharing the design details in your blog post. So this will definitely catch the attention of the hiring manager. This is something that industry experts are looking for. They need people who can do things like this when they are in college. And when you go to the last bullet, here you're not saying that you know Python, C. What you're saying is, I know that language and have used it to actually automate a design. So you're not communicating that you know Python. You're actually saying you are actually putting it into some use, right? So that's a very powerful way to say that you know the programming, and also you're making it to putting it into good use. You're also doing some automation work, which also shows your analytical skills, right? So this is what a hiring manager would really be looking for in your resume. So try to be more precise and use some powerful words. In the next the next slide, I will give a brief summary of a few points that you can keep in mind while you build your resume. You go backwards in time, you give your recent achievements first, and then you go back in time. And then you use powerful, strong words. You quantify your work, which is very important. You quantify what you have accomplished. And you also know what the company is looking for and tailor your resume accordingly, right? And the last bullet is very important. Sometimes we see a lot of resumes with 3 or 4 pages, and a lot of things are written, but nothing really very powerful. Keep it to not more than 2 pages. And one more thing is, even if the hiring manager only looks at the first page, that itself should be good enough to pick your resume. So you should have all the important contents in your first page. Right? And finally, when you are writing your resume, ask this question to yourself: are you differentiating yourself enough from the others? Are you doing something extra? That is a key question to ask when you build your resume. Okay, I see some questions. Yeah.
Yeah. So on the chat, thank you, Shanta. Shanta has explained that you're actually demonstrating impact statements, how they highlight one's accomplishment. And Shalini had a question saying, can we say that a resume deals with how we are putting all our knowledge into practice? And what is your...
Exactly. Yes. Yeah. Perfect. Actually, that is exactly what we're looking for, right? So you have studied a lot of courses, you have attended conferences, but what is the outcome? That's exactly what we're looking for. Because everyone can go and attend a lot of lectures, everyone can go online and read a lot of things, but what is sticking with us? Like, what are we doing out of that, right? So that is what the hiring manager really looks for. Perfect. Yeah, Shalini. Okay, now I want to take this resume further, and you remember we had this mentor feedback, right? In step 2, we got the feedback from mentor. Those are the things that are listed on the left side. And now what we can do here is take those feedback points and convert that into some action. For example, the strong RLC MOSFET basics is right there in the resume on the right side. Now, what are we going to do about this feedback that we are not very strong in the feedback loop concepts, the control systems and stuff like that, right? So you and your mentor can come up with a goal that says you're going to do this op-amp topology survey, right? So if you have to do that, you're going to watch a lot of online courses. You have to understand that you should be really good in this feedback concept. Otherwise, you cannot actually create a survey like that, right? So that would become your goal. And you put that in your resume blueprint. I call it blueprint because you're putting something which you are not yet accomplished, but that is going to act like a to-do item for you, right? So you're going to overcome your weakness in your feedback concepts by doing this work. And eventually going to put it in your resume and show it to the hiring manager that you are really good in that. And similarly, what are you going to act on the next feedback, weak IC design fundamentals? So that is where you're going to do that oscillator design that we talked about earlier. So there you provide all the specifications. So if you want to improve your IC design skills, this is a very nice project to pick up, right? So that becomes your goal to improve on the IC design fundamentals. And similarly, strong analytical skills, a very good way to demonstrate that is to automate something, right? If you want to automate something, you have to be really good in the equations, the analysis. You're going to make a machine do it. So that means you have to be really good at it. So that is what you will put in your resume eventually. So these are the things that you want to have in the resume. That means that becomes your blueprint or the call for action. In the next step, you're going to see how you're going to get there. From the feedback, how are you going to convert that into accomplishments? So that's what we're going to see in the next step. Okay, I see one more comment. I would add putting relevant knowledge towards the purpose of resume.
So KG is a SIGANA volunteer and a 2014 alumnus. KG works at Exhaust Trucks in the Bay Area. I think he's sharing a comment here.
Okay. Okay. Hi, KG. Thank you.
Yeah, no worries. Thanks.
Okay. All right. Now, the next step is getting down to action. This is where we're going to build the skill. We have a goal, we have the feedback, and we have the call for action. We have put that in our resume blueprint. Now, how are we going to accomplish that? How are we going to acquire that knowledge? Okay. So this is again a very critical part. Thanks to the internet, there are now various ways to build our skills. Okay, so again, I'm restating what we just now discussed. We have the mentor feedback, we have the resume blueprint, and what comes in between is your action plan. Okay, now how do we build our skills? Like how do we act on all those feedback that we got from the mentor? So there are various ways to do that. We are all familiar with this. One way is to go online, like learn from online materials, online courses. The other way is to learn from textbooks. And another way is to interact with your mentor, have online sessions with your mentor who has expertise in the areas that you are trying to improve upon. So that is another way to gain knowledge. And you can also do some mini projects. You can build a product or do a design. You can learn hands-on, and you can also learn from your elective courses. You can pick courses which will give you new knowledge, right? So that is another very good way to learn something new. And finally, a very direct way of getting that experience that the industry is looking for is to do an internship. So, I mean, everyone knows that these are different ways you can acquire knowledge and make your weaknesses into your strengths. I'm going to touch upon just a few items here in the next slide. I'm going to talk about the online course, the textbooks, and the projects. Okay. Some of the online courses that I found very useful. I have actually gone through some of these courses. I'm again talking about analog design. That is the example goal that we have taken. So there are many good courses in NPTEL. Many professors like Aniruddhan, Nagendra Krishnapura, Dr. Shanti Pawan, excellent materials available online. We can go through those NPTEL courses from IITs. You have a lot of YouTube channels, excellent material. Even professors have their own channels now. If you want to learn about power electronics, there is wonderful online YouTube videos, also from Professor Ben Yako. And also you have Coursera. Everyone is familiar with Coursera. You have excellent courses on power electronics, Dragan Maximovich. And the good thing is almost all of these are for free, right? So you can watch it anytime. It's all for free. When it comes to textbooks, I know all students, we all follow certain textbooks in college as part of the college curriculum. Here, what I want to emphasize is we also find out what are the books that are used by engineers when they are actually doing their designs. What are the books that they use, right? Sometimes there is an overlap between the textbooks used in the industry and also the textbooks used in the college environment. But it will be good to actually compile a list of books that are used in the industry. For example, when I do IC design or when I started learning about all these amplifier designs, I was using this book by Razavi, A Design of Analog CMOS Integrated Circuits, extensively. It was a wonderful book. Also, then a little advanced book is this Analog Design Essentials. So like this, there are books in for every domain, right? I'm only talking about particular analog design and power electronics, but we can find out more from the alumni network and from engineers. What are the books that they follow in different domains, like digital electronics or mechanical engineering, or whatever it is, right? And if you also get hold of these books and prepare from that, it will be very helpful to connect better with the industry, what is being done in the industry. And the final item is building a product or design. This is your final year project. That will also be discussed in the next step, so I will skip it for the time being. And that is also a great way to build your skill. Okay, once again, I have a few questions for students to respond. One common thing I hear from students, mainly not from engineers, but mainly from students, is there is a lot of online resources. And when we watch those videos and lectures, it seems that it's all very familiar. We are able to understand it really well. But then after some time, it fades away, right? It's not sticking with me anymore. And again, when I try to actually do a design myself, nothing really comes to my help. Like whatever I have watched is actually not sticking to me. So if you feel something like that, then please choose 0. And in case you feel that you are getting lost with so many learning resources, we click on this video, then we go to another video from there, we keep moving, but finally we don't know which one to actually pick and stay with. So if you think you need help getting a suggestion of a handful of good learning materials that are really relevant to the industry, if you would like to get something like that, please go with choice 1. Some of us can work on these things. That's why I would like to know what will be really useful for you. And in case you think you can find relevant online materials and you're able to also understand the concepts, but the problem that you're facing is time. Like you have all these semester exams, assessments, midterm. You have the projects that are also going on in your college curriculum, and you're not finding enough time to master these other topics that you can learn from online. So if the time is a problem, please go with choice 2. But if you think you are fine and you can make best use of the online resources and you have already made significant improvements using those online materials in understanding the subject, please go with choice 3. May I request you to give your response now? Okay, I see a 2. That's good. Okay. All right. So, okay, very interesting. I was not expecting choice 2, but many of you are finding time as a problem. Okay, both 0 and 2. Okay.
Most 2s and then a 0 maybe.
Okay. All right. Okay, thanks for sharing your feedback. Any more comments? Any other questions at this time before we go to the next step?
So one question that has come up from Shalini is from which year is an internship preferable?
Well, an internship, I think if you can get an internship even in your second year, first year is more general. You will be going through humanities and other general engineering, mechanics and everything, right? So even if you can do an internship in second year, I think it is still good because getting exposed to industry is always good. But typically, even hiring managers look for candidates who are in the third year because they are already exposed to certain core concepts, core topics, right? So they want to pick students who are in their third year of engineering. That is the typical profile of students who are getting internship opportunities. So I would say third year is probably ideal. Fourth year, anyway, you'll be starting to look for jobs. So fourth year might be a little late. So third year would be ideal for internships, I would say.
And
okay.
KJ is adding a comment saying that to support the textbooks list that you had mentioned, Bhaskar, that keeping a list of textbooks that one has used over the years to go back and relearn and refer would be helpful. And actually, as part of CEGian, there's one other aspect that I would like to mention. So in Ask a CEGian, there is a particular arm called GOLD, which is Gindi Online Live Database. It is it's like a Wikipedia for CEGians or engineering students, where it's a great place for all these resources that you've, these links and resources that you've shared, Bhaskar. Actually, there is a section for online courses and publicly available materials. So after we're done here, I'll share a link to it and would really appreciate if you can put these materials or links in there.
Oh, certainly, yeah, SK, that would be great. I was not aware of that. Yeah, I will try to learn more about that, and definitely I will share what I have.
Thank you so much.
Thank you. Okay, so I will go a little fast. We are so okay. We have 10 more minutes. I'll try to go a little bit faster now, if my slides can move faster. Okay, we are at step 5 now. So we have built the skill that are required. Now we're going to talk about the final year project. I have called it as final year product. Like if you can make your project as a product and you build something for the real world, that would be really great, right? Of course, if you want to do something theoretical, that's fine too. But from the engineering perspective, if you can make your final year project as a product, right? That is also a nice segue into getting into entrepreneurship. Like it can be, it will help you jumpstart your startup career in case you want to start a startup, right? So that's a great place to start with. Now, I want to share a few points on this topic. So let me get to that next slide. Okay. Now, when we talk about final year project, we really think about it in the last year, right? What I would urge the students to do is, if you can actually think about it in your third year, like who are the teammates, who are the other fellow students you're going to work with, right? I mean, we may think that it is easy. Your friends are going to be there and you're going to do that final year project with your friends. You have to think again, because your friends may have different aspirations. They may be your close friends, but finding like-minded classmates to work with is very key, right? So you and your teammate should both be in sync with what you're going to do as your final product. So this, though it might look trivial, I think this is a very important piece in making sure that you do a successful final product. And how do you learn product development? There are, again, tons of material online. You search in YouTube, you get a lot of videos. I recently watched one video and I found that very impressive. It's live entrepreneurship. It's the title goes like, what you should know before you take the plunge. This is a short video for entrepreneurs who want to do something of their own, right? They want to develop a product. Now, this talks about 5 key questions that any entrepreneur should ask himself or herself. I'll list those 5 key questions that are prescribed in that video. Okay, so what problem does your product solve? The target customer. Do your customers believe this problem is worth solving? And will they be willing to pay for it? And what is the biggest obstacle to success? So these are the 5 questions. If anything that you want to do as your final project, if you can ask these 5 questions to yourself and get a good answer, right, that will give you a lot of clarity whether that is worth doing or not. So this was a very good learning for me. I wanted to share it with all of you. It's simple 5 questions, but they are all very powerful questions. It will give us a lot of clarity as to what we want to do and whether it is worthwhile. All right. And a few more points. I think I have one more slide on that. Yeah, some product examples, right? Like when I go and give a talk in some colleges, I'm in Coimbatore, I go and give talk in to nearby colleges. And some of the questions that students ask is like, what are the things we can do as final year projects? Right? I also go for final year project evaluation. So they call me for evaluating their final year projects. And I often find that they are not of the high standard. So then students ask me, what are the things that we can do? There are a lot of things we can do. There are many ideas we can come up with. There is no paucity of ideas. I just have a few things which is of interest to me. It may not be of interest to you, but these are just some examples, right? You go to the lab, you always see all those bulky power supplies. A simple thought like, how small can we make it? Do we really have to have that so big? Sorry, I think my slide went too fast. Let me get back up. Okay. Can we make the power supply really small? Do we really need that big a supply? And can we make a low-cost clicker for classroom interaction? You can do online search what a clicker means. It's you can make it as it's like an RF project. It's an analog project. Can we make it as a low cost? Right now it is costing around $300, $400. It's very expensive. Can we make it for a very low cost? The third point is like, how can we simplify home wiring? Now we have all these LEDs. We are using LEDs as our tube lights. We also have BLDC fans, which runs in DC. We also have our UPS, which is battery for 24 volt or 48 volt battery. In case you have solar power, that's also giving you DC. So there's a lot of equipments in our home which are running from DC. As of today, we are converting all that into AC, or we are converting AC back to DC and then using it for our home appliances. Can we have something where both of them coexist? You use AC power for your heavy loads like washing machines and refrigerators. You use DC power for your fans and lights. Can we come up with a wiring which will be reducing the cost of wiring itself? Like modern homes, we can save some cost in coming up with a different wiring. Can we make a low-cost USB-C power delivery adapter? Like this USB power delivery is a new standard. It's picking up really well. Can we make a low-cost adapter which can go into the wall sockets? The last one is the fun part. I play chess, and I'm curious. Can we make a chess robot which can detect your move and also move pieces like mini drones? Like I'm sure we can all come up with a lot of ideas like this if you do some brainstorming with your mentor, with your fellow students. It'll be very interesting to come up with more ideas and see if it is of practical value. Again, you ask those 5 questions, and it can be your final project. It's as simple as that. Okay, now we are at the last step. This is about cracking your interview, right? Again, this is very important. We have built all the skills required. Now, how do we handle the interview, right? Interview is a process. We need to be familiar with what the interview process is, so that we can tackle it really well. Okay, let's get to those slides. And yeah, we have a few more minutes. Okay, the best way to know what a company is looking for is to actually look at the interview evaluation sheet. A hiring manager has to fill this sheet after he or she interviews you. And this is a sheet from 2 different companies. And the key points, I don't know whether it's all readable for you, but both these sheets are talking about the same skill set that they're looking for. I have summarized that in the next slide. Typically these 4 skill sets are often coming up as the evaluation metric. The first one is the technical fundamentals, problem solving, work attitude, and willingness to learn. For the technical fundamentals, we already discussed how you're going to build your skills. There are so many ways you can build your skills online. You can do projects and so on. We already discussed that. One of the other key ways to actually strengthen your fundamentals is to teach your juniors. When you have to teach something, that is when you actually gain a lot of expertise in that. So when you sit to figure out how we are going to teach something, that's when we actually learn a lot. I have personally had a lot of experience here. When I want to teach the juniors something, that is when real learning happens for me. So that's a very powerful way. You can use your college environment. You can go teach your juniors certain topics that is of very much interest to you. Problem solving. You can do projects. You can take up mini projects, which will give you a hands-on experience. That is a great way to improve your problem solving ability. You can do some design automation. Your final year project is a great way to improve your problem solving abilities. And the last 2, the work attitude and willingness to learn, I'll put it into one bucket. And so how do we get the right attitude or the mindset? How do we improve our learning ability and become more willing to learn? It all depends on your presentation skills. How often are you going in front of your fellow students to present something, share some ideas? And are you able to listen to the questions that are asked? Do you have the patience to listen and respond? How are you handling those questions? Are you able to think about some concept which you do not understand? And are you able to stay with that question for long, right, until you find the answer to that? And are you able to learn beyond your curriculum? So these are some of the things that you can keep in mind, which will help you develop the right mindset and help you develop the skills that are required by the industry. Okay. Okay, and very important, you also have to familiarize yourself with the interview process. I think we are running out of time. Maybe I will skip this. You can just go through these points. It's nothing very new, but maybe I will highlight one. Yeah. Yes,
Bhaskar, do you have a time constraint? If the students don't have a time constraint, we organizers don't have, at least we can stay a little longer, so not a problem. So if you'd like to go on, please go ahead.
Okay, sure. Yeah, thanks. Then I'll take a few more minutes to wrap up. So familiarizing yourself with the interview process. So there are 4 key points I've highlighted here. The first thing is, it's interesting. The interviewer also has his or her own limitations, right? So they can only ask you questions which they are comfortable with and which they use at work regularly. For example, let's say you are an expert in Nyquist criteria, control system, something like that, right? Let's say you're an expert in Nyquist criteria. But unfortunately, the person who is going to interview you, they do not use the Nyquist criteria regularly at work. They use body plots for finding out system stability, right? Then you will never get a chance to actually display your skills. Like, you may tell them, but they may not actually question you in that topic. So you also need to comprehend what is actually used in the industry. What are they actually working with on a daily basis? The questions are going to be coming only from that, right? So that's a fundamental thing you have to realize and prepare accordingly. And the second point is also very important. Like many students that I interview, they will talk a lot about some specialized topics. That is very great. Like they have actually spent some time on chaos theory or like DC-DC converters, stuff like that. That's great. But then if the candidate is not answering the fundamentals very clearly, if they're not very good in the fundamentals, right, like simple RC circuits or MOSFETs, basics, things like that, then that is not going to help them in the interview. So we have to be good in fundamentals and then say, hey, I'm also good in this. I also know this. So that that will be appreciated. And the third point is it's the student's responsibility to get the question right. Now, oftentimes what happens in the interview is there is a question and then the student tries to answer something else, right? And mostly the questions can be open-ended, right? When the interviewer asks a question, the question may not be complete. So it is the responsibility of the student to actually ask more questions to get the original question right. So that is how you can actually understand what the hiring manager is looking for and then respond accordingly. So that's another key piece of advice or suggestion, I would say. And the final point is also very important. We need to practice on thinking out loud when we solve a problem, especially with this pandemic situation. It becomes even more important. It's all done through video conferencing and over the phone. And when we give a problem to the student, and if the student goes quiet for say 2-3 minutes, we have no idea what is going on in the student's mind, right, or the candidate's mind. So it becomes important to you as a candidate, you have to walk through, you have to talk, like say it aloud, what you're going through, like what is your thinking process, right, when you try to solve a problem. That's a very key piece of it's a key skill, I would say. It's a skill that you need to develop so that you are comfortable thinking out loud, and you also help the interviewer understand you, and then the interviewer also guides you, and then you solve the problem. That will be a very nice experience. And finally, you definitely seek for opportunities for mock interviews. The interview should not be your very first experience of getting interviewed. You should already have prior experience. You should request your mentor or your seniors who have already given some interviews to conduct some mock interviews for you. Nowadays, we know what kind of questions are asked in general. So it's not going to be very difficult to conduct mock interviews. In case you get access to some engineers working or who are also hiring managers, they can also help you with mock interviews. And there is not a set of questions that interviewers ask, right? So there is no set of like question bank. So the mock interviews will give you an idea what kind of questions that you will get. But more than that, it is mainly the experience, like how the questions are and how you are responding to that. Are you able to comprehend it? And are you able to think through that? So that experience is more valuable than knowing what kind of questions are being asked in the interview. All right. I think, yeah, now this is the last slide I have. I want to summarize what we discussed so far. We talked about 6 key steps that any student can pick up to navigate this path from campus to industry, like from academia to industry. The first one we discussed is the curriculum map. You choose your electives wisely. The second step is setting your goal, and you get a mentor and get a reality check and set your goals accordingly. And the third step is to act on the feedback that you receive, and you build a resume blueprint, which will act as a to-do list for you to accomplish. And okay, and then now you get down to action. You start building skills that are relevant to achieve your goal, and then you do you focus on your final year project. The request here is to try to make it as a product so that it also helps you with your entrepreneurial aspirations. And finally, you get familiar with the interviews. You connect with people. You apply for the openings. You get yourself familiar with the interview process. And yeah, so these are the things I would like to suggest. I hope this would help anyone succeed or achieve the goals, the aspirations that they have. Please feel free to reach out to me. You can email me rbhaskar@gmail.com, or you can also connect with me via LinkedIn. Bhaskar is my LinkedIn profile handle. Okay, if there are any questions I can take. I think there is one question in the chat. How can we get into companies like Texas Instruments, Analog Devices, Qualcomm, Cypress? Okay, if they don't visit our campus. It's electronics in general. I'm on my final year and those companies haven't. Yes. Okay, so this campus interview, you're right. Meaning all companies, they don't visit all campuses. For example, TA, they have a massive hiring process. They send their engineers to various IITs. They also visit like Anna University. They visit PSG. Sometimes they go, sometimes they don't. Yeah, if they don't visit your campus, how can you apply for those? No, like if you go to LinkedIn, the HR from TA, they often share posts. They say that there are openings available. I've seen that several times. So LinkedIn is one very good way to actually get in touch with the HR, and you can apply to those openings. Right? And all your resumes go into a common pool. I think this is the case with any company. And then the hiring manager gets to see, there will be initial filtering done by the HR, and then the hiring manager gets to see those resumes. And if your resume stands out, then you have a very high chance of getting picked, getting a call. So what is key here is building skills that differentiate you from others, right? And with today's information availability, you can definitely make that happen, right? You have all the resources available to you, so you can certainly make a difference. You can differentiate yourself from others. You can get called for interviews. So look for openings through LinkedIn. I don't know what else, what other ways you can find out. You can even apply directly to many companies. One thing I did personally when I finished my master's, there was no campus there, right? I did my master's in US, University of Colorado Boulder. I just went to all these companies' websites, including TA, Analog Devices, Maxim. I just find some email address there, HR email, and then I just go and apply, create resumes for each company. Now I want to tailor my resume for each company, depending upon the openings that are available. And I contacted a lot of companies, and I did get called from those companies. So it was not through campus, it was just by direct email. And eventually I was able to get, like 7 job offers. Without any campus. So it is possible if you are able to differentiate, if you are able to create if you're able to build good skill sets, then you can directly go contact those companies. You'll be called.
Thank you, Bhaskar. And one more question, if it's all right. Alifia is asking that they're saying that thank you for the valuable advice, and they're a second-year EEE student. How can I figure out which domain of electrical field I want to work in, like renewable energy, signal processing, battery management for EVs, etc.? Okay.
Yeah, no, all these are very exciting fields. Renewable energy, that's a very exciting field. A lot of research work being done. My professor, University of Colorado Boulder, Dragan Maximovich, he has completely switched to renewable energy research, signal processing, battery management for EVs. Again, very exciting fields. I would say you spend some time going through these areas, right, and see what is of interest to you. Like, are you very excited about the upcoming EV? Are you excited about sustainability? Like, for example, building a home that can be self-sustaining. You generate the electricity that is required for the home. So you see where you're calling this. You get to know more about these domains. And then I think you will then be able to clearly say, okay, this is what I want to do. And then once you narrow down to one particular domain, then in that particular domain, you have to find out some experts, some industry experts or engineers who are working in the domain, or even professors. And then that they will help you take the next step forward. So for the first step, definitely it should be something of your liking, because everything is exciting, right? All these fields are great fields to work on. So yeah, please do more research. I think you will definitely find out which is your calling.
Thank you so much, Bhaskar. If it's all right, if I could ask one question.
Sure.
You had shown, how a final year project a student can take up and work on a product, and which is great. It is much easier to do in the software world because much of the the pieces of software are open sourced. But to be able to do anything in the hardware design world, I'll have to really have a Cadence subscription or an FPGA. These pieces of software are expensive. Sometimes in the university, the professors don't have an idea of what to buy, or they don't even have that kind of an exposure. Are there any either open source tools that can be used by the students? Or if not, what kind of programs exist? I know there is a lot of university support programs and so on that the universities can avail and students can avail of.
Okay, that's a very good question. Actually, you are absolutely right. In fact, I always envy the software domain because it's so easy to build something in software. And I sometimes even have cursed myself, like it becomes so difficult for me to even make an IC. I'm as an IC design engineer. There's a lot of steps involved. You need a fab, you need the PDKs, the process development kit. You need a tool like Cadence, and there are not many such tools available. There is not much of open source. Things have changed now. I'll come to that. But yes, there are a lot of roadblocks if you want to get into IC design and make something of your own, right? Now, then what else can we do, right? If IC design is like that, it's not going to be that easy. As a final product, right? A product need not always be an IC. You can also do it in a discrete fashion. For example, you can pick ICs that are manufactured by companies. You can put them together to make something worthwhile, right? For example, the projects I have listed, can we make a USB-C PD, like USB-C power delivery adapter? How effective, how efficiently can we make it, right? It will be to some extent limited by the ICs that are available, but can we add something to it? Can we add a microcontroller to it? Can we make it low cost? Can we make it work with a very cheap microcontroller? So there are things that we can do beyond IC for sure. So having said that, now even in the IC ecosystem, right, things have changed a lot. Now Google has the Skywater PDK. They are actually supporting. They are making a free PDK available online, and there are a few universities who have picked up, and they are providing a complete suite of open source software using which we can do a complete IC design. Personally, I have not myself done that yet, but I have gone through all these open source, and I am also trying to install them in a like in a server, Linux server, which can be accessed by students. So if you can actually put all these open source tools together and make it possible to build an IC, it is definitely already possible. Universities, professors, they have actually offered, they're also offering courses in which they teach us how to do that. I can share some links, and I'm also researching into that. And even in the IC space, it is going to be pretty much possible in the next few years. So that's also very exciting. And yeah, definitely things are looking very promising now.
That's really exciting to hear. And, that's a wonderful note to hopefully conclude as well. Thank you, Bhaskar. This was a fascinating talk. I hope all our students take advantage of it and hope they benefit from it. Thank you for really providing the time, and when things are so hectic in the professional world. And thanks to all the organizers, the volunteers for really helping organize this webinar. And students, thank you so much for participating. Do let your friends know about the mentoring program, Ask a CEGian, all three arms of it, the webinars, the mentoring program, as well as the gold, and share it with all your friends so that they all benefit from it as well. And, thank you, Bhaskar. Thank you again, and I will end this recording now.
Yeah, thank you very much, SK, and thanks to everyone who has helped organize this event, and thanks for the opportunity. Thank you very much.
Thank you so much.
Have a good day, everyone.
Good day.
Thank you,
Bye.
sir. Thank you so much.